SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering basic and applied. Today we shall discuss about the basic differences between SI and CI engines, and then we shall discuss about the compression ratio, that is an important term used to in the context of the operation of the internal combustion engines. So, before coming to the discussion of the comparison of SI and CI engines, I would like to recall the differences between 2-stroke and 4-stroke engines that we have discussed in the last class. Now, if we write the 2-stroke and 4-stroke engine, two-stroke and 4-stroke engine. So, what we have seen that for 4-stroke vis-a-vis 2-stroke, for the 4-stroke cycle engines, whether it is SI engine or CI engine, we could identify that if I write here 2 revolutions of the crank per cycle, while for the 2-stroke engine there is 1 revolution of the crank per cycle, right. So, whether the engine is SI engine or CI engine, for both SI and CI engines, if the engine is 4-stroke cycle engine, then we have discussed per cycle we could identify 2 revolution of the crank, while for the 2-stroke cycle engine only 1 revolution of the crank per cycle. Now, I am coming to this particular point. Since 1 revolution of the crank per cycle, and we have seen that there is 1 power stroke in a 2-stroke engine, 1 power stroke vis-a-vis 1 ideal stroke. So, 1 power stroke per revolution and 1 revolution per cycle. So, that means in a cycle 1 power stroke is there, while if we try to recall for if we discuss if we consider 4-stroke cycle engines, 2 revolution of the crank, and we have seen that out of these 4 different strokes, 1 is the power stroke, remaining 3 strokes are the ideal strokes. So, in there is I mean for 2 revolution only 1 power stroke. So, engine is getting enough time for the to get cool down, but for the 2 stroke cycle engine 1 power stroke occurs on 1 revolution of the crank. That means per revolution 1 power stroke, theoretically 1 revolution half power stroke. So, basically 1 power stroke for 2 revolution, 1 power stroke for 1 revolution. That means the rate of occurrence of power stroke and consequently the power output theoretically appears to be double for the 2 stroke cycle engines as compared to that of the 4 stroke cycle engines. So, let me write here the rate of occurrence of power stroke and consequently power output theoretically appears to be double. So, this statement what I have written over here, this is valid if we compare with 4 stroke cycle engines. So, this is as compared to that of the 4 stroke cycle engines. It is because of this reason, because we know that power stroke is the stroke during which pressure and temperature inside the cylinder, pressure and temperature of the working substance inside the cylinder is very high, and it is because of this reason several parts of engine or engine cylinder may prone to mechanical failure due to thermal stress, and accounting for this aspect, speed of the 2 stroke cycle engine is reduced. So, let me tell you once again, since the rate of occurrence of power stroke, that means the power output which we have discussed now seems to be theoretically double as compared to that of the 4 stroke cycle engines, and it is because of this reason speed of the 2 stroke cycle engines is reduced. Otherwise, excessive rise in temperature may lead to the failure of several mechanical components owing to the thermal stress generation or development. But let me tell you why I am discussing this particular point, because this is the most important and fundamental difference between the 4 stroke cycle and 2 stroke cycle engines. This is one important aspect, that speed needs to be reduced. Also, we have seen that for the 2 stroke cycle engines, significant portion of the fresh charge, that is the fuel air mixture if it is SI engine, or the fuel for the CI engine will be lost, because the intake and exhaust, these 2 strokes occur simultaneously. So, when fresh charge is drawn into the cylinder by a suitable pressurizing system, the incoming fresh charge allows combustion products to go out from the cylinder. Now, that simultaneous intake and exhaust stroke leads to a loss of some fuel. So, we cannot eliminate that particular aspect. So, though speed of the two stroke engine, so basically we have seen that the speed of two stroke cycle engines needs to be reduced, needs to be reduced, because otherwise excessive rise in temperature may lead to the failure of several mechanical components. On the other hand, large amount of fuel loss will be there due to the two different stroke. We have that part we have discussed in the last class. The simultaneous intake and exhaust strokes. So, incoming fresh charge is allowing combustion products to go out. So, that particular process will result in a significant loss of the fuel with the combustion products or combustion gases. On the other hand, though there is only one power stroke vis-a-vis 3 ideal strokes, yet the greater asset of the 4 stroke cycle engine is the fuel economy. So, that is very important part. So, for this particular class of engines, 4 stroke cycle engines, let me write over here, that is greater asset is the fuel economy, right. So, you know that 4 stroke cycle engines we are getting only one power stroke. So, the power output theoretically lesser as compared to that of the 2 stroke engine, that is there, but the greater asset is the fuel economy, because the loss of fresh fuel that is inducted into the cylinder during intake stroke through charge, if it is SI engine, I mean the loss can be prevented. So, that is why 2 stroke cycle SI engines are not recommended. So, it is because of the loss of significant amount of fuel, 2 stroke cycle SI engines are not recommended. Okay. So, with this discussion, because this is very important point I wanted to discuss today, next we shall discuss about the differences between SI and CI engines. So, you know that 4 stroke vis-a-vis 2 stroke, this classification is based on the number of strokes, while this classification of internal combustion engine is based on the types of combustion. So, this classification is that we have discussed. So, this is based on the types of combustion. Okay. So, if we now discuss about, I mean if we discuss the difference between SI and CI engines, so if I write this is SI engines and then this is CI engine. Okay. So, if we discuss now so while we are trying to find out the difference between SI and CI engines, let me tell you, if we try to recall internal combustion engine nomenclature, that time we have discussed that except two parts, those are the spark plug and carburetor, other parts are same for both SI and CI engines. That means, for the SI engine we have seen that there is a spark plug that is used to initiate spark for the combustion, and another component is the carburetor that is provided to supply homogeneous mixture of fuel and air. The same nomenclature can be used for the CI engine, provided carburetor is removed and spark plug, instead of spark plug there will be a fuel nozzle. So, from that particular point, if we discuss the differences between SI and CI engines, we must say that both SI and CI engines have much in common, but still there are a few fundamental differences, and those differences make the operation of both SI engine and CI engine to be different. So, while we are trying to figure out the fundamental differences, we need to find out a few common point basis. So, the first basis point is the basic cycle. Basic cycle, you know that just if we try to draw over here, say we have so this is top dead center, this is bottom dead center, and we have one spark plug. So, this is intake manifold, this is spark plug, this is exhaust manifold. What we have seen that during intake stroke, piston is coming from TDC to BDC, fresh air is coming through intake manifold into the cylinder. Next stroke is, if we consider 4 stroke cycle engine, next stroke is piston is again travelling back from BDC to TDC, both the valves are closed and the inducted phase charge is now getting compressed. Towards the end of the compression stroke, if we switch on the spark plug, spark will be initiated and that spark will help to ignite the compressed charge. Combustion will be completed, and because of the combustion, high pressure and high temperature, the state thermodynamic state inside the cylinder is the high pressure and high temperature of the working substance that is there. That will create a thrust on the piston face, and piston will again travel back from TDC to BDC, and that is the power stroke. And since the movement of the piston is spontaneous, because the amount of power that we are getting during power stroke will remain stored in the flywheel, because this is crank and this is connecting rod. So, that crank will be rotating, and that crankshaft, the flywheel is connected to the crankshaft, and that crankshaft will again borrow energy from the flywheel for the movement of the piston between TDC and BDC during 3 different ideal strokes. Now, question is what we need to do if we need to know the if we need to estimate the efficiency of the internal combustion engine, how much power is being produced or how much power is getting how much power is available at the crankshaft. To know that, we need to know the change in pressure, volume and other thermodynamic properties, right. So, question is, so that means to map the functioning of a 4-stroke cycle engine, whether it is SI or CI engine, we need to know we need to map all the processes in different thermodynamic planes. That means, we have understood that intake, compression, power and exhaust. So, these 4 strokes will occur in a cyclic manner. So, that means, all the processes if we can map in a thermodynamic plane or thermodynamic planes, then perhaps we can represent the cyclic processes, we can represent the cycle to be precise. So, in other word, we need to know a particular cycle which will allow or which will map all the processes in different thermodynamic planes or ordinate diagram. So, the basic cycle for analyzing the performance of SI engine is the Otto cycle. So, I am writing over here, that is the Otto cycle. See, the name Otto is coming because a German inventor, Nicholas Otto, who invented this, and he is credited, Nicholas Otto is credited as the first creator of the operation of 4-stroke cycle SI engines using one particular cycle, and that cycle is Otto cycle. So, this is analyzed, the basic cycle is Otto cycle, which is used to describe the functioning of SI engines. Okay. So, this is very important. The German inventor Nicholas Otto, who is the German inventor who first introduced or who first described all the processes or functioning of 4-stroke cycle SI engine using this cycle, and that is why it is Otto cycle. The basic cycle for the CI engine is diesel cycle. Again, let me tell you, if this is the schematic for a CI engine, then the spark plug should not be there. Instead of spark plug, a fuel nozzle will be there. And if we need to describe the functioning of the 4-stroke cycle CI engine, we need to map all the processes in several thermodynamic planes, and German inventor or mechanical engineer Rudolf Diesel, who first described the functioning of CI engine using a cycle, and that cycle is known diesel cycle. So, Rudolf Diesel German inventor. He was a mechanical engineer. Okay. So, diesel cycle is used to describe functioning of four stroke cycle CI engine, 4 stroke cycle CI engines. Okay. So, this is the fundamental difference based on the base, I mean when the basis is the basic cycle. Next is again let me write, this is SI engine and this is CI engine. So, next is the basis on which we can differentiate the operation of CI and SI engines. Next is the introduction of fuel. See, for the SI engines we have seen that carburetor is there. So, carburetor is provided to supply homogeneous mixture of air and fuel. So, this is what is there, while for the CI engines, as I said that instead of spark plug we will have fuel nozzle. So, fuel is introduced in the cylinder by using a fuel nozzle, while air is drawn into the cylinder through intake manifold, right. So, this is the difference between SI and CI engines when the basis is the introduction of fuel. So, we are trying to figure out the fundamental differences. Next is the ignition system. So, if we go to the next slide, next is, so this is SI engines and this is CI engines, right. So, if we write, next is the ignition system. See, for the SI engine we know that spark plug is there. So, spark is initiated by the spark plug and that spark initiate combustion, while for the CI engines we have discussed that the pressure and temperature at the end of the compression stroke, pressure and temperature of what? Pressure and temperature of the air, because air is drawn into the cylinder through intake manifold, that air is compressed and at the end of the compression stroke thermodynamic state of the compressed air is such that when fuel is sprayed into the compressed air, that thermodynamic state allows fuel to ignite. So, that is called auto ignition. So, here we can write that spark plug is used, to ignite the charge. So, charge is fuel plus air mixture. Okay. Charge or fuel air mixture. Spark plug is used, while for the CI engine utilizes the high pressure and temperature of the compressed air that is at the end of the compression stroke. Utilizes the high pressure and temperature of, or let me write, utilizes high pressure and high temperature of the compressed air to ignite the fuel when sprayed into the cylinder by a fuel nozzle. So, when fuel is sprayed into the cylinder, because cylinder is having compressed air. So, essentially fuel is sprayed into the compressed air by a fuel nozzle, and CI engine utilizes high pressure and high temperature of compressed air to auto ignite the fuel. So, that is the fundamental difference between SI and CI engines, when the basis is common basis for this particular comparison is the ignition system. Then is the compression ratio. So, next basis is compression ratio. SI engines are having relatively low compression ratio. So, this here compression ratio, if I write here compression ratio, that is CR is 5 to 10.5, while CI engines are having higher compression ratio. And CR is 10 to 22, CR compression ratio varies from 10 to 22. Last common basis for this comparison is, so if I write SI engine and CI engine, so the last basis is the weight of the engine. CI engines, weight of SI engines is low, while weight of the CI engines is very high. Now, so these 5 base, if we try to go back to the slide, so we had started discussing about the fundamental differences between SI and CI engines, right. We had identified 5 common bases. One is the basic cycle, another is the introduction of fuel, third one is the ignition system, fourth is the compression ratio, and last common basis for this comparison is the weight of the engine. Now, the last point, weight of the SI engine is low, while weight of the CI engines is very high. So, if we go back to the previous slide, wherein we have written the difference based on the compression ratio, SI engines are having relatively low compression ratio 5 to 10.5, while CI engines are having high 10 to 22. So, you can see, if we now look at carefully the last 2 points, low compression ratio, low weight, high compression ratio for CI engines, high weight. That means, weight of the engines, this particular point is directly related. So, the difference between SI and CI engines based on the weight or on the basis of the weight, which can be directly related to the compression ratio. So, we shall discuss about this, what is compression ratio, because we have seen that these 2 points are interrelated. So, now let us quickly discuss about what is compression ratio. So, I am writing here compression ratio. That is here. So, if we try to draw the engine cylinder, so these 2 points are this is top dead center and this is bottom dead center, okay. And so, this is intake, this is exhaust, okay. So, if we now try to see the so this is volume V and this is pressure. So, if we try to draw the change in pressure volume when piston is, so this is bottom dead center and this is top dead center, say 1. So, when this is the configuration, when piston is at BDC, say this is VBDC and this is the volume, say this is the pressure. So, this is the base pressure. So, when piston is coming from BDC to TDC, both valves are closed in the compression stroke, volume will reduced. So, when piston is at BDC, that is in the beginning of compression stroke, entire you know this cylinder passage is cylinder space is filled with fresh charge, both valves are closed, piston is travelling back from BDC to TDC, volume will reduce, pressure will increase. So, now if we say this is the point and this is the, so this is VTDC 1 and pressure will increase. So, this is the change in pressure. So, you can see that as piston travels from BDC to TDC during compression stroke, volume reduces, definitely volume of the compressed charge, volume of the charge will reduce, pressure will increase. Here you know that if we write here, this volume, so this is the volume. So, you know this length, particular length, if we now look at this two dimensional schematic, this length over which piston is having to and fro movement is known as stroke length, and the volume in three dimensional space is the swept volume Vs. So, if we now look at the two dimensional schematic, we can see only the length, and that is the this is the length over which piston is having reciprocating movement, and that length is stroke length. In three dimensional space it is the volume, and that volume is stroke volume Vs, while the volume between the top dead center and the cylinder head. So, this is cylinder head, is the known as clearance volume. So, that is this is the clearance space. So, when we are trying to compress the fresh charge, if it is SI engine, or compress only air for the CI engines, the compressed charge or compressed air will occupy this space, that is known as clearance space. So, this is the volume between top dead center and cylinder head. Compression ratio is defined as the ratio of total volume by the clearance volume. So, that means CR equal to Vc plus Vs divided by Vc, that is 1 plus Vs by Vc. So, the total volume is Vs plus Vc, clearance volume is Vc, and this is 1 plus Vs upon Vc. Now, let us consider another case. Case is, say, this is another configuration, and this configuration, so this is TDC 2. So, this is another configuration where TDC is here. So, what we can see from this schematic depiction is that we are trying to reduce Vc, we are allowing stroke length or the stroke volume. So, if we consider configuration 2, BDC is remaining same. So, that means we are increasing Vs, that is the stroke volume, but the clearance volume is getting reduced. So, if we now look at what we can see, I mean just if we plot, so if this is VTDC 2, then we can see volume will reduced during the compression stroke definitely. So, pressure will increase further. So, now if we consider that configuration 1 for SI engine and configuration 2 for CI engines, what we can see? So, that means Vc is for configuration 2, Vc is less. When Vc is less, CR will be higher, right. So, higher compression ratio. So, to have higher compression ratio we need to reduce Vc, and that is the configuration 2, that is for the CI engine. So, for the CI engine what we can see, maybe we are compressing to the extent. So, we are trying to compress the fresh air up to VTDC2 and increase in pressure. So, basically now it was, so this particular pressure is say P2 and this particular pressure was P1. So, you can see P2 is greater than P1. So, the pressure at the end of the compression stroke will be definitely higher for configuration 2, that is the CI engine we have considered over here, because compression ratio will be high. So, if we increase the compression ratio, what we can see, Vc must be reduced. The consequence is that pressure will increase, and that high pressure will allow fuel to auto ignite the moment when it is sprayed into the cylinder by a fuel nozzle. Now, question is, that is what we have understood, but issue is if the compression ratio is high, then we have seen that the weight is also very high. Why? Because you know that pressure for the higher compression ratio, pressure developed inside the cylinder is very high. So, to withstand that pressure, basically that time both valves are closed and engine cylinder is acting like a pressure vessel. So, to withstand that high pressure, cylinder will be thicker. To be precise, wall of the cylinder will be thicker and weight will automatically increase. So, that is why if compression ratio increases, weight also will increase. That is what we had written earlier. So, to summarize today's discussion, we have tried to discuss about the most important difference between 4-stroke and 2-stroke cycle engines. Afterward, we have discussed about the fundamental differences between CI and SI engines, and finally, we have introduced one important terminology, that is compression ratio. We have defined, and then we have discussed the consequence of the higher compression ratio in the context of internal combustion engine. With this, I stop here today. We shall continue our discussion in the next class. Thank you.